Hello students, in this video we'll discuss about basic instruments. It is mentioned as basic instruments in the mechanical syllabus, but of course in the ECE it is mentioned as electrical and electronic measuring instruments. In electrical and electronic measuring instrument, this is one of the topic. Let us see some basics related to this topic. Let us say this is a ammeter and this is the pointer. So this is 0 and 1 and 2 and this is 3. Let us say it is a ammeter and it is connected in the circuit. So we are expecting in the circuit, as per the theory calculation, some 2 amperes of current. So the force or torque which exerts on the pointer to move from one position to other position is known as deflecting torque. And because of the deflecting torque, let us say pointer started moving, but we are expecting it should stop at 2 ampere, but indefinitely it is moving to 4 amperes. Therefore there should be some opposite force or opposite torque should exert on the pointer so that it will stop at 2 amperes. That force, that opposing force which opposes the deflecting torque, is known as controlling torque. When deflecting torque is equal to controlling torque, pointer will come to the rest position or steady state position. Because of the inequality between the deflecting torque and controlling torque, let us say we are expecting pointer to stop at 2 ampere, and at this position deflecting torque and controlling torques are equal. Due to the internal construction of the systems used to provide controlling torque and deflecting torque, due to the inertia of the systems, sometimes due to inequality between the deflecting torque and controlling torque, this pointer will start oscillating about its final position. It is moving about 1 ampere and 3 ampere, then 1.5 ampere and 2.5 ampere, and finally it will come to the 2 ampere. These are called oscillations. So to reduce these oscillations, one more torque we are using. That torque is known as what? Damping torque. So in indicating, therefore in indicating instruments we use three types of torques, that is deflecting torque, controlling torque and damping torque. Now quickly we'll revise the formulas in the basic instruments. So first classification of the instrument is absolute instrument and the second one is secondary instrument. So absolute instrument is nothing but what? They indicate the value directly without any calibration. Whereas in case of secondary instruments, some calibration is required. Usually these secondary instruments are used for calibrating the absolute instruments. And second classification is indicating instrument, integrating instrument and recording instrument. These indicating instruments, they show the value directly, like ammeter, voltmeter, wattmeter. And integrating instruments means they give the some cumulative value over a period of time, like energy meter it will measure the power with respect to some time, and energy meter, total flow meter and odometer, all these are example for integrating instruments. And a recording instrument, like earthquake intensity is recorded by seismograph and heartbeat is recorded by ECG. And in case of substation, the fluctuations in the voltage or variations in the voltage are recorded by recording voltmeter. And the example for absolute instrument is a tangent galvanometer, and secondary instruments like ammeter, voltmeter, glass thermometers are secondary instrument. And here this energy meter is an example for integrating instrument. This is very important bit. And seismograph, ECG, recording voltmeter are example for recording instrument. These are the very important bits. Usually deflecting torque is directly proportional to the current in case of ammeter. Deflecting torque is directly proportional to the current. In case of voltmeter, deflecting torque is produced by the voltage to be measured, but that voltage also is proportional to what? Current. So ammeter and voltmeter both are directly, in both the cases deflecting torque is directly proportional to the current. That's the reason they call as current measuring instruments. To provide a controlling torque, we use two types of mechanisms. So one is spring control torque. So in case of spring control torque, controlling torque is proportional to the theta. Theta is nothing but what? Twist in the spring. So angle of twist in the spring. So controlling torque is directly proportional to the theta. So In case of spring control, if I use the spring control in any instrument, the deflection is directly proportional to the current to be measured. Therefore, we will be having the uniform scale. So when I use the spring control mechanism in the instrument, will be having the uniform scale for that instrument. So second one is gravity control. So in case of gravity control, controlling torque is proportional to sine theta. So we have here I proportional to sine theta. We'll get the non-uniform scale in case of the gravity control. We discussed damping torque is used to reduce the oscillations in case of the pointer. So here we are seeing some damping curves. So on x-axis I have taken the time, on y-axis I have taken the deflection. So if the instrument is under damped, that means oscillations will be there for large time. After large time, the oscillations becomes to zero. So when the instrument is over damped, then the instrument become slow, and when the instrument is critically damped, the oscillations becomes to zero very quickly. So in this chapter we will see about only two instruments, that is PMMC, permanent magnet moving coil instrument, and other instrument is moving iron type instrument. First let us see PMMC, permanent magnet moving coil instrument. In case of PMMC instrument, deflecting torque is equal to NBIA. N is a number of turns in the coil, and B is a flux density, and I is a current to be measured or current flowing through the coil, and A is the area of the coil. So deflecting torque is equal to NBIA. It's very important formula. Based on this formula, we have some simple problems. So from this, deflecting torque is proportional to current I, and controlling torque we provide spring control mechanism. So TC is equal to KC into theta. At steady state condition, controlling torque is equal to deflecting torque. Then we'll get the condition K theta is equal to NBIA. KC theta is equal to I is nothing but what current, NB V by R into A. So here A is nothing but what area of the coil. Now how to extend the range of the ammeter and how to extend the range of the voltmeter. How to extend the range of the PMMC ammeter. See, this is the ammeter. So let us say its capacity is 10 amperes, but I want to extend this 10 amperes to some 20 amperes of current. So I want to make this ammeter to measure 20 amperes of current. Then in such case, what I have to do? I will be connecting low value of shunt resistance in parallel with the ammeter, so that whatever the high current to be measured, that majority of the current will be flowing through the shunt resistor and low current will be flowing through the meter, so that meter will be safe. As the shunt resistance value is low, majority of the current will be flowing through the shunt. So by using the low value of the shunt resistor, we extend the range of the ammeter. So what is that value of shunt? So RSH is equal to Im by ISH into Rm. Very important formula. I is the total current that to be measured. Im is the current flowing through the meter. ISH is the current flowing through the shunt. I by Im is equal, from this I by Im is equal to 1 plus Rm by RSH. M is the multiplying power or multiplying factor. So that is equal to M is equal to what is the formula? I by Im. Very important formula, I divided by Im. And here one more very important formula, RSH, shunt value resistance, is equal to Rm by M minus 1. RSH is equal to Rm by M minus 1, that M is equal to I divided by Im. And Rm is the internal resistance of the meter, RSH is the resistance of the shunt, Im or If is the full scale deflection of the current. I nothing but what is the current to be measured. ISH is current flowing through the shunt. So in this way we extend the range of the ammeter by connecting the shunt resistor in parallel with the meter. Next, extending the range of the voltmeter. How can we extend the range of the voltmeter is, we connect a high value of resistance in series with the meter. High value of resistance is connected in series with the meter. So this is called series resistance or series multiplier. So again, what is the value of series resistance that we are connecting? V minus Im Rm divided by Im, and that series resistance equal to, very important formula, m minus 1 into Rn. In case of R is equal to m minus 1 into Rn, this is the series resistance value, where m is the voltage V divided by meter voltage, or voltage to be measured divided by meter deflection, meter reading. Now we'll see the second instrument, that is before going to the moving iron instrument, about the PMMC instrument. PMMC instrument is only used to measure DC. It will not measure the AC. Now we'll start with the moving iron instrument. Moving iron instrument is used to measure both AC as well as DC. So what is the deflecting torque is half I square into dl by d theta. So theta proportional to I square. As the square is there, it also measures AC as well as what it also measures DC. So this is very important. Theta proportional to I square. This moving iron instrument will have the non-uniform scale. In moving iron instrument, we have two types of instrument, that is moving iron attraction type moving iron instrument, repulsion type moving iron instruments. Now let us start with some practice questions on the basic instruments. An ammeter is a dash type of instrument. Ammeter is a indicating instruments. Answer is A. Which is an integrating instrument? Energy meter is a integrating instrument. Integrating meters are used for the measurement of energy. So because in case of energy meter, power is integrated with respect to time. Integration P dt will give us the energy. Next, indicating instrument, the deflecting torque. In indicating instrument, the deflecting torque is produced by using the following effect. So control spring means it will provide the controlling torque. So magnetic effect will give us the deflecting torque. In indicating instrument, the control torque is provided by, control torque is necessary for. So control torque is necessary for steady deflection or causing deflection of the system is nothing but deflecting torque. Deflecting torque will move the pointer. Moving the pointer is nothing but deflection of the pointer. So damping torque is used for reducing the oscillations. So steady deflection, so that means pointer has to come to the rest position. So we use the controlling torque. Next, the damping usually provided in indicating instrument having weak magnetic field. So when in the instrument, the magnetic field which we are using for operation of the instrument, if it is so weak, in such case we will be using the air friction damping. Because eddy current damping we cannot use. Eddy current damping also requires some again magnet, so it may destroy the main field magnet. So air friction damping does not require any magnetic field, therefore it is used in the instrument where operating magnetic field is weak. When the operating magnetic field is weak, we use the air friction damping. Example, moving iron type instrument. In indicating instrument, the damping is usually adjusted. So damping is adjusted to the critical value. Damping is adjusted to the critical value to show the accurate reading. When the pointer of an indicating instrument comes to the rest in the final deflected position, then dash torque is 0. Now pointer is already came to the steady state position. So there is no damping torque required. So damping torque becomes what? 0. Damping torque can be produced by eddy current. We have three types of damping torque: air friction damping, fluid friction damping, and the third one is eddy current damping. In eddy current damping, the disc is usually made up of. So usually the disc has to carry the current. It should be conducting and non-magnetic material. Answer is D. Air friction damping is used in the instrument, which is in case of moving iron instrument we will use the air friction damping. Next, Which of the following can be used to extend the range of ammeter? So in case of range of the ammeter, just now we have seen low value of shunt resistor, low resistance in parallel with the ammeter is used. So answer is C. PMMC is used to measure DC. Answer is A. A meter that is capable of measuring DC only is moving coil. PMMC instrument can be used only for DC. Answer is B. Which of the following meter has a uniform scale? Moving iron will have non-uniform scale. PMMC instrument will have the uniform scale. Answer is A. The scale of voltmeter is uniform, then its type is moving iron permanent magnet. So it's not moving iron, it is moving coil permanent magnet. Next, moving iron instrument is used to measure both AC as well as DC. So moving iron instrument will measure both AC as well as DC. The scale of the moving iron instrument is cramped scale. It is a cramped scale, non-uniform scale. It's a cramped scale. Cramped scale means at the starting it is very nearby grouped, and later the distance between any 2 points will be increasing. Moving iron instrument will have dash scale like cramped scale, or it is also called a squared scale. So answer is B. Which of the following methods are used for producing the damping torque in analog instrument? Air friction damping is used, fluid friction damping is used, eddy current damping is used, and electromagnetic damping is used. So answer is all the 1, 2, 3, 4. Thank you. This is a small video on the basic instruments.